Hello everyone and welcome to this question. So let's have a quick read of this. So you got this diagram, you got this shaded region here. The diagram shows the curve 5 minus x multiplied by x minus 1 and the line x equals a. Given that the total area of the region shaded is 19 units, determine the exact value of a. Okay, so the best way to deal with this question is first let's deal with this area here. Let's split it up. Okay, so when that factorizes, you know that x equals 1 is going to be where it's going to cross here, and you know when x equals 5 the quadratic is going to cross here, and we need to find what a is. Okay, so first thing what you could do is you could integrate between so now you could do this simply on your calculator. I'll do it longhand, but you could simply just put the limits 5 and 1 in your calculator and get this straight out. So if I expand that all out, I'm going to get 5 times x is 5x. Let me just do it the long way. Minus 5. Then you got minus x squared and the plus x. I'm going to integrate that with respect to x. Okay. Before I do anything, I'm going to 5 and 1. I'm going to collect the terms together. So I've got minus x squared. That plus that is 6x and minus 5. And add 1 to the power shared by new power. So that's going to be 1 to the power shared by new power. Add 1 to the power, which is going to be x squared. Shared by new power, which is going to give me 3, and that's going to give me minus 5x. And then I'm going to plug in the limits 5 and 1 into these. So I'll put the 5 in, I'm going to get minus 125 over 3. 5 squared is 25 plus times 3 is 75. Minus 5 times 5 is 25. And then I'm going to plug in the 1, substitute the 1 in, that's going to give me minus 1/3 plus 3 minus 5. If I put that into my calculator, you're going to get, right, I'll just quickly do it here. So the minus 125 over 3 add, okay, just say add 50, it's going to be minus minus becomes plus 1/3, and that's going to be 3 take away 5 is minus 2, minus minus becomes plus, so that's a plus 2. You end up with 32 over 3. So that's the area for this, 32 over 3. What we want, we've been given that, let me just, if I change that, that's going to be 10 and 2/3. We've been told that plus that is going to be 19 units. So if we do 19, subtract the 10 and 2/3, you're going to get 8 and 1/3. Okay, so that tells us that the area below this graph is going to be 8 and 1/3. So now, because it's so we need to find what a is. Because this area is below, that will become a negative. Okay, or another way of saying it is if I just keep that but I flip those signs. So what I could do is I could there's my integral, but instead of 5 I'm going to put a there. We'll change that for a. We want the limits between 5 and a. Now I am going to do it in that order, because I know normally you would say integrate between a and 5 and that will give me negative, but because I'm going to negate that area and I make it positive, I'm going to change the limits on here, which you can do. So that means if I keep it like that, this here stays the same. So what did I get here? Let me just say, so here I'm going to just plug that straight in. So I get minus 125 minus 125 over that's going to be plus 50. So that part here, when I plug it in, I'm going to get, so literally, let me just say that again, I'm putting in the limits in this expression, x cubed over 3 plus 3x squared minus 5x, 5 and a. So if I put the 5 in here, I'm going to get 25 over 3. And then if I put the a minus, put the a in here, so that's going to give me minus a cubed over 3, 3a squared, and minus 5a, and that's going to equal 8. Well, I'm going to put that over 8, 16, 24, and 25 over 3. Okay, which is the same as that. So what I can do is I can subtract that from both sides. That makes maths a bit easier. And I could times everything by this negative to make that positive. So I end up now, actually I'm not going to do that. I'm going to take the negative back in. So I'm going to get, so I took that from both sides, and then negate all this bracket will give me a cubed over 3 minus 3a squared, minus minus becomes a plus 5a, and that's going to equal 0. And if I multiply everything by 3, I'm going to get a cubed minus 9a squared plus 15a, and that's going to equal 0. Now if I bring it to this side, if I now factorize this, take the a out, so I'll get a, I'll end up with a squared in here minus 9a plus 15 equals 0. Okay, and then if I factorize that further, thinking what numbers, 3 and 5 and was 15. Yeah, I'll this one will not factorize. I'm just going to double check it. So 1 and 15 won't give me it, 3 and 5 won't give me 9. So you can have a equals 0, which we know it obviously isn't, and then this one we'll have to factorize by using completing the square or the quadratic formula, but I'm just going to complete the square. So that's going to give me a minus 9 over 2 squared, take away that squared, which is going to be 81 over 4 plus the 15 equals 0. So minus 81 over 4 plus 15 is minus 21 over 4, which I'm going to take to the other side. So I'm going to get a minus 9 over 2 squared is going to give me 21 over 4, and if I get rid of this square by square rooting all this, which will give me 21 over, and that's going to be a plus or a minus, over 2. Then I can take the minus 9 over 2 over, so a would equal 9 over 2 plus or minus 21 over 2. Now we know that a is going to be greater than 5, okay, because it goes from there. So therefore we can't minus, this is 4.5, can't minus anything on it. The only solution is, therefore a must equal 9 plus